Dear third prep, Assalamu alaikum wa rahmatullah wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Unit 3, Lesson 1. The lesson is called Dispersion, okay? And this is the last unit with us. This is the statistics unit. In this lesson, we have two lessons, collecting data and dispersion. The most important lesson in this unit is the dispersion. Okay, first we need to know what the meaning of the dispersion. Okay, dispersion means the divergence of the difference among its values. What does it mean? If we have some data, okay, in this data, for example, the marks of the exam, the math exam in a class. Okay, if we have a difference or a gap between the values or the marks, okay, to measure the difference, or this divergence, so we measure the dispersion. So the dispersion means the gap or the divergence between the marks or between the data. Okay, like this, the dispersion measure that express how much the sets are homogeneous. What does it mean, word homogeneous? Homogeneous means that the values are like to each other or have near levels about each other. For example, if I have a class, if most of the students, okay, have a good level, okay, then this students are homogeneous. Or in another class, if we have the students are low level, okay, then also this students or this class is homogeneous. But in a third class, if we have some students have a perfect level and another students have low level, so this class is heterogeneous because there is a difference or gap between the level between the students. Okay, finally, the dispersion measure this heterogeneous or measure this homogeneous in this class. Okay, now the most important concept, how can we measure the dispersion or the gap between the values inside the class? Okay, to measure the dispersion we have two methods. The first way called the range. Okay, what is the range? The range is the difference between the greatest value and the smallest value. We studied this concept before in the primary stage. Okay, for example, and this is very important, every year there is a question related to the range in the exam, inshallah. Okay, the value of a set A are 60, 58 and so on, and I need to measure the range between the values. The range here equal the maximum value minus the minimum value, which is equal 4. Again, the range equal 62 minus 58, which is equal 4. The range is the simplest measurement of measuring dispersion. Okay, because the range is a very easy like this, just I'm going to select the maximum and the minimum, I'm going to subtract them, so the range called the simplest measurement of dispersion. The other part of the measurements called standard deviation. Okay, what is the standard deviation? The standard deviation is the positive square root of the average of squares of deviations of values from their means, and denoted by this symbol which called sigma. Okay, we don't need to memorize this definition, but I'm going to explain what the meaning of this definition in the next examples. Okay, here the dispersion or the standard deviation, okay, called the most important, common and accurate measurement of dispersion. Why? For example, if I need to measure the dispersion inside a class, okay, if I used the range to measure this dispersion, So I'm going to start to choose the maximum mark and the minimum mark and subtract them. Okay, what will happen if most of the marks are about 15, 16, 17, 20 and so on, and one mark is, for example, 2 out of 20. In this case, we have a very large gap between the data, so the range doesn't give me an accurate measurement because most of the class higher than 15, okay? And so this is a very excellent class, but only one from the students has lower level, okay, than the others, so this measurement is not accurate. But the standard deviation, okay, to measure the standard deviation, I'm going to collect all data, all marks, and find the mean, okay, and finding the difference between the data, the marks and the mean, and collect them, find the sum, finding the sum, and put the sum inside square root, so that the definition says that this is a positive square root of the average of deviations, and so on. So the standard deviations gives me a very accurate measurement for the dispersion. Now let's solve the first example related to the standard deviation. Okay, here in this example, calculate the standard deviation of the values 12, 13, 16, 18 and 21. First, I'm going to draw a table formed from 3 columns. Again, draw a table formed from 3 columns like this, okay? Okay, but before drawing the table, I'm going to evaluate x bar. What is x bar? X bar, okay, this is the mean of the values. So I'm going to evaluate x bar. I'm going to add 12 plus 13 plus 16 plus 18 plus 21 over their number, which is 5, because I have 5 values like this. So x bar equal what? Equal 16, okay? Now I'm going to draw the table as I said before. Here I'm going to write x. What is x? X is the values 12, 13, 16 and so on, okay? The values are 12, 13, 16, 18, 21, and down I'm going to write the sum. Here I'm going to write x minus x bar, okay? X dash called x bar, okay? This is the rule of this column, x minus x bar. So I'm going to do what? 12 minus 16 here. Its value equal negative 4. 13 minus 16 equal negative 3. 16 minus 16 equal 0. And 18 minus 16 equal 2. Finally, 21 minus 16 equal 5. Here I'm going to write x minus x bar all power of 2 like this. I'm going to make negative 4 all power of 2 like this. 12b 16, negative 3 all power of 2 equal 9. 0 power of 2 equal 0. 2 power of 2 equal 4. And 5 power of 2 equal 25. Finally, I'm going to find the sum of these values, which is equal 54 as we see. Finally, what is the standard deviation, or what is the sigma? The sigma equals square root sum. This symbol means sum, okay? X minus x bar all power of 2 over n. N means the number of values, which is 5. So I will have square root 54 over 5. It will be like this. This is approximately equal 3.286. Another example for the standard deviation. Okay, we have another example. Find the following distribution of number of defective units which found in 100 boxes manufactured units. Okay, here in this example he asked me to find the standard deviation, okay, like this. Here the number of defective units 0, 1, 2, 3, 4 and 5, and the number of boxes as we see is the other column 3, 16, 17 and so on. The first row is called X and the second row called K. So I will write a table formed from 6 columns like this. The first one is X, so here I will write X. X is the first row, which is 0, 1, 2, 3, 4, 5, 6, 5, and so on, okay? The second row is K. I'm going to write 3, 16, 17, and so on. Okay, 3, 16, 17, 25, 20, and finally I'm going to write the sum of them, which is equal 100. Okay, here I'm going to write X times K. X times K, 0 times 3 equals 0, 1 times 16 equals 16, 2 times 17 equals 34, 3 times 25 equals 75, 4 times 20 equal 80. Here 5 times 19 equal 95. Okay, finally I'm going to add them. It will be 300. Okay, now I'm going to reach this part. I will evaluate X bar. X bar equal what? X bar equals 300 over 100. Again, X bar equal sum of X times K, this sum, over sum of K equals 300 over 100, which is equal 3. Okay, now back to this table. I'm going to write here X minus X bar. X, these values, 0 minus 3 equal negative 3, 1 minus 3 equal negative 2, 2 minus 3 equal negative 1, 3 minus 3 equal 0, 4 minus 3 equal 1, and 5 minus 3 equal 2, okay? Here I'm going to write X minus X bar all power of 2. So I'm going to make all this column to the power of 2 like this. Negative 3 power of 2 equals 9, 4, 1, 0, 1, and 4. Here I'm going to multiply this column by this column. Okay, this column times this column. Okay, 3 times 9, 27, and 64. 17 times 1 equals 17. 25 times 0 equals 0. 20 times 1 equals 20. 19 times 4 equals 76. Finally, I'm going to add this expression, this one. It will be 204. Finally, sigma. Sigma equal what? Equal this sum over 100 over this sum. Equal the sum square root sum X minus X bar all power of 2 times K over sum of K, which is equal to 104 square root 204 over 100 like this, which is equal approximately 1.428. Okay, and this is a very important part in this one, and this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullah wa barakatuh.